Hello, in this lesson, we're going to talk about simple trig equations. Of course, this is one category of if statement. In these if statements, of course, the outputs are given about a function, right? In the last lesson, which is the lesson right before this one, we have an overview about the function, right? Function is a rule that has inputs and outputs. For each input, there's exactly one output. And when input is given, it's a vertical line. We draw a vertical line and hit the curve. So we get the point. The point as input and given the output, it will also tell us the related output. When the output is given, that's typically an if statement. Okay, so this is the second kind of statement we're talking about. So specifically, we have categorized, the if statement we are going to be dealing with. One category is trig equations or inequalities. And the other category is exponential or log equations. And the next one is inequalities. And also there's a quadratic, absolute value, polynomial, square root inequalities. So we're going to talk about these with concentrated topics. And today we're going to talk about simple trig equations. Simple trig equations. Okay, so example. Example number one. Okay, what is a simple trig equation, right? Say sine x is equals to half. Okay, for consistency, what we did before, so let's use a capital A, right? So because the input for a sine is our angles is equals to half. So first we want to understand what it means, right? So that's what we always talk about. What's the meaning? Okay, I'm sure this question for many of you is actually pretty simple. It's pretty simple, but there are some very important points we need to make here. Number one, what is the meaning? What is the meaning? Right? If we understand the meaning, right, of a simple one, then we will be able to understand how to handle cases like what if sine A equals to 1/3, right? Which is not a special angle. And we should also be able to handle if sine of A equals to -3/5, such as these examples, right? So you can see that they're really similar questions. So that's why we need to understand the meaning. Okay, so we want to develop a specific idea, methods to handle all of these. Okay, regardless of what output is given, we will be able to resolve the question. Okay, so let's look at the first one, right? What's the meaning? The meaning, okay, so we're going to put this as these two questions for later. So what is sine of A equals to half, right? So this basically tells us that the angle is the input and sine rule is applied. The rule of sine is applied to it. So the rule of sine is applied to it. It produces output, and the output is half. The output is half, okay? And we want to identify, okay, what's wanted, right? Wanted is to identify, okay, or find all possible input, possible values for A, right? Such that, and that statement is going to be true. We're going to find all possible values for A. And of course, we know that the answer are going to be in the domain of sine. Okay, so we need to recognize number one, okay, the solution, okay, all the solutions to A are in the domain of sine function. Okay, and number two, then these is the question is, how do we get them? How do we get them, right? How to, right? So our solutions are in the domain of sine function. So what is the domain of sine? Well, the domain for sine is all real numbers, right? It's all real numbers. And so let's see how we're gonna get those solutions. There are two ways to get it. Okay, so if we think out loud, okay, all of these I'm writing down here is we're gonna categorize them as think out loud. Think out aloud. Okay, it's not something you're gonna turn in. Is these are things you're gonna scratch and you scratch paper to try to figure out. In the end, I will show you how do you show work. Right? How do we show work? You don't have to show every way we do it. Okay, you don't have to show every way we solve these equations, but you should show one way of solving this equation and clearly and correctly and with logic. All right, so let's see. How do we resolve this, right? In the last lesson, we talked about there are typically more than one way to do it. In the case of ARD, right? So in our case, what is the situation? We have A, we have R, we have D, right? So we basically know D, right? So from D, we're gonna find what? We're gonna find A. From D to A. This is D to A, right? We know definition. So what is a definition? Right? We can go by unit circle, right? We can go by unit circle if you wish, because this is gonna, you guys can see it. This is gonna be a special terminal. Well, you don't have to go to unit, you go by unit circle, okay? So I'm going to show you a couple of ways to do this, because we also, in the process of doing this, we also want to develop means to handle non-special cases. Okay, so if you simply know how to solve this one, and you don't know how to solve the other two, and then what's the point? Right? We haven't been able to solve any questions related to it. So this is D to A. The first way, okay, the first method, okay, we're going to use that unit circle. Okay, so how do we use that unit circle? Many of you probably, it's very good at using that unit circle. So let me see if I can find that unit circle in my document and bring it to us, right? So we can make use of it. Where's my unit circle? It's not in this spot there. Okay, I know it's somewhere. All right. The first method is probably the most common method. Okay, you have seen that. Okay. Here, remember, our goal is to develop certain methodology so we can solve a situation, we can solve a question of similar type, no matter it's special or non-special. That's the goal. So we're not just to solve one single question. We basically want to know how to fish, right? Instead of just being given a fish. All right, so if you know that sine A equals to half, right? We're looking for the blue number half, right? So where's the blue number half? Do we find them? And we found the blue number half. Because the blue numbers are sine values, right? The blue values are sine values. Blue numbers are sine values. So we found 2, right? There's one here, and there's another one over here. So we get 2 terminals. So that's R, right? Reference angle, because these 2 terminals tell us basically it's reference angle. We already know the reference angle right there, right? Maybe I shouldn't be using these colors. I should be using blue color. Blue color is no good. Just try to make some distinction, okay? But anyway, so I think you understand. So there's 2 terminals. There are 2 terminals. Okay, are there other terminals? Right, so from definition, we get to the reference angle, right? The reference angle are pi over 6, right? You see, that's a D. From D, we get to R, and then we get to find the angle, DRA, okay? Does that make sense? I hope that makes sense, right? So I just want to see DRA. Remember, we're trying to develop a methods to handle questions of similar type, regardless it's special or not, right? So in this case, we have identified 2 terminals, right? So that's from definition, we have identified 2 terminals. That's the reference angle because they both have the same reference angle. And this reference angle is pi over 6, and this reference angle is pi over 6, right? Reference angle is the positive acute angle between the terminal and the x-axis. So we have 2 terminals. And A is angle measurement, right? A is about this angle A here, right? So what will be the possible values of A terminating either on this terminal or the other terminal? And how do we measure angle? Every angle as input for the trig functions are measured from the standard position, right? So now we're doing DRA, we're doing the A. So let's measure the angle. So we could measure, we measure from the standard position, pi over 6, 5 pi over 6, okay? And so we keep going, we get all these angles, right? Whether we measure counterclockwise or clockwise, we get a negative 7 pi over 6, right? Negative 11 pi over 6. So we have tons of solutions. Right? So let's see if there's any pattern. Right? So we're going to find a pattern. We're going to find the patterns. So when we try to find the patterns, we see, oh, look at that, right? So on this terminal, how do I describe all the angles that terminate on this first terminal in the first quadrant? Well, the reference angle is pi over 6, right? So A could equals to, there are 2 cases, right? There are 2 cases. And so there could be, so let me write it down. Okay. Hold on. I'm going to need the curly bracket. Okay. And there are 2 cases. The 2 cases, right? Sorry, this one moved, right? So these 2 software don't talk to each other, but I'm going to just clear all and let's focus on the first one, right? So on this terminal, all the angles that terminates on this terminal can be described as what? As pi over 6, right? Plus what? Plus 2k pi. 2k pi, because on this terminal, right? On this terminal, if I start a measurement, so pi over 6, right? And if I measure another angle and I will go around, that's a pi over 6 plus 2 pi, right? I measure another angle and there, negative, 2 pi minus, I'm sorry, pi over 6 minus, because this is how we measure from standard position, right? So you measure, that's going to be negative 11 pi over 6, right? So it's pi over 6 minus 2 pi, right? So terminating on this terminal, all these angles are here, okay? Now, we have another terminal, don't we? We don't want to forget that. So there's another case, 5 pi over 6. So the next one is 5 pi over 6. 5 pi over 6 plus 2k pi. 2k pi. Why 2k pi? Well, k can be any integer. K can be any integer. So I'm going to specify k to be any integer. To be any integer. So what does that mean? See, if 1k, so now we already found the solution. I just want to show you why these are all of these are solutions. Okay, so by this time we have found all the solutions. Let's make sure we understand all of these solutions. Let's make sure we understand all of these solutions, right? So for example, with that solution, right? Since the k is any integer, k can be 0. K can be 0. When k is 0, right? So what are the solutions? We got a pair of solution, k is 0, right? K is 0. K is 0, right? So what do we get? We get pi over 6, right? We get pi over 6 or 5 pi over 6. So those are solutions. If k equals to 1, right? If k equals to 1, what do we get? We get another pair, right? 2 times 1 times pi, right? And this is 2 times 1 times pi, right? So that's plus 2 pi, plus 2 pi. So what is pi over 6 plus 2 pi? What's pi over 6 plus 2 pi? Pi over 6 plus 2 pi, right? If you measure the angle starting from the standard position, right? Pi over 6 plus 2 pi, you come around, you terminate the same terminal, right? And 5 pi over 6, the same. 5 pi over 6, right? You measure 5 pi over 6 and plus 2 pi, you go around. That's 5 pi over 6 plus 2 pi, right? So you can keep going. So that's how all these solutions are covered. Let's just try one more. What if k is negative 1? What if k is negative 1? Right? If k is negative 1, right? If k is negative 1, what we will have is that k becomes negative 1. Oops, sorry. Negative 1, remove that. And k is negative 1. Negative 1. And what does that equal to? That's basically pi over 6 minus 2 pi, right? That's pi over 6 minus 2 pi. Pi over 6 minus 2 pi. What does that equal to? Minus 2 pi, right? 2 pi is 12 pi over 6, right? It's 12 pi over 6. Okay? So that's going to be equals to negative 11 pi over 6. Okay, what is a negative 11 pi over 6? Negative 11 pi over 6 is basically an angle measured from standard position clockwise boom, right here. See, it ends there, right? So that's when k equals to -1, right? That's when k equals to -1. So how about 5 pi over 6? 5 pi over 6 minus 2 pi. So this is going to be 5 pi over 6 minus 2 pi. Okay, 5 pi over 6 minus 2 pi. Right? You can also measure this way, 5 pi over 6, and you go back -2 pi, right? You go back -2 pi. So what does this equal to? Let's get the numerical value if you wish, right? So that's equals to, well, 2 pi is 12 pi over 6, right? 12 pi over 6. And what does that equal to? Well, that equals to -7 pi over 6. 7 pi over 6. What's -7 pi over 6? -7 pi over 6, if we measure the angle, is going to be clockwise measurement, right? -7 pi over 6. This is pi, -7 pi over 6, right? So it's, you see, all of these angles terminate in the same term, in either one of the terminals. So there are solutions. So this general form represent all the solutions, Then you say, how do I show work, right? How do I show work? Well, when you show work, we already showed you how to show work, right? When you show your work, really all you need to show is just this piece. Just show this piece, right? You tell the reader, right? You have this unit circle, and then you just give the solution like that. And you have all of those mental work we just explained inside your mind. And you don't have to write in great details about it. So your teacher can understand, you understand. So this is the first method, right? I believe that most of you probably know this. You probably know this, right? So let's talk about the second method. Okay, I want to talk about the second method. Remember, we want to get systematic ways to solve any questions of such nature. Okay, not just one. So method 2. Okay, method 2, instead of using that unit circle, okay, I pretend I don't know that unit circle. I don't know that unit circle, but I know the definition. I know ARD. Okay, we know the D, right? In this case, we know D. In this case, we know D, right? ARD. So in the definition of trig functions, I hope you guys still remember what the definition of function, right? What's the definition of function? What's the definition of sine? What's the definition of sine? I hope you guys still remember, right? So after we describe A, after we describe R, and then we describe the definition. Definition says an x comma y is any point. Okay, x comma y is any point, right? Is a point on the terminal side of the angle other than the origin, okay? And the R is equals to square root of x squared plus y squared. Okay, and sine of the angle is equals to what? Y over R. Y over R. And here we go. Y over R is half. Y over R is half. There you go. So we know because the point can be arbitrary. We only need to know one point, right? We only need one point. And when we talk about y unit circle, we say any point will do as long as it is not the origin, excuse me. And so we know this is half. This is half, right? So y, you can think of y is 1, r is 2. Are you guys with me? So we can think of y is 1, r is 2. Right? Y is 1, r is 2. So what kind of situation is that? So let's draw a rectangular system. Let's draw the rectangular system. See, we go back to the definition. Definition is really our fundamental, okay? When we go back to it, you will find, oh, you always have a way to deal with these questions. We always have a way to deal with these questions. Okay, so I'm just going back to the definition. Okay, I'm just making some adjustment to my system, to my rectangular system, because in my definition, right? So in my definition, and so sine is 1/2. So y is 1, r is 2. So how do you draw a triangle? Well, how do you draw? Because you know that y is the blue number, right? Y is the blue number and r is 2. So you basically kind of draw, you're basically drawing something like you're going to draw a, you don't know what the x is, right? So there's some x here, right? So think about the scenario by definition, okay? Think about the scenario by definition. We don't know x. X is a red number, right? We don't know what it is, but we know y. Y is the blue number, right? Y is the blue number, right? And what is r? R is 2. I don't want that blue, so I'm going to make that green. How about that? Right? So this r is green. So what do we know? We know that r is 2, y is 1, and this is a right triangle, right? This is a right triangle, so we can figure out what is the red by Pythagorean theorem, right? And so that's the terminal, right? That's the terminal. And for such terminal, so what angle would that be? Well, for the same terminal, right? We have many, many angles corresponds to it. But is this the only terminal? Well, obviously not. On the other side, we also have a r, right? Because sine is positive, positive, negative, negative. So we have another blue, which is r, which is y equals to 1. And of course, there's another red, right? So we found our two terminals. We found our two terminals. So let's see, let's mark these numbers, right? So this is 1, and this is 2, 1/2, and this is 1, right? And this is 2. Okay, so let me put the 1 outside so it looks better, right? And of course, on this side, the red is positive, and the other side, red is negative, but we're not interested in the red number, right? We just have to identify the angles. We just have to identify the angles, right? And then you have this triangle. So this side is 1, this side is 2, and we try to find the angles, don't we? We try to find the angles. So then you just, we know this is special, right? We are, by this time, we already know it's special. If you don't know it's special, it's not the end of the world either, because you can just draw this blue 1, right? Look at that. This is 1. So you eventually figure out this is a special. This is special. That's what I'm trying to show, okay? If you draw this triangle, then you realize this is 1, this piece of blue is 1, and that's 1. So the whole thing is 2. And this is 2, this is 2. And this is isosceles, right? And what else can we do? What very soon you realize this is actually a third, pi over 6, 30 degree. So in the case of special angle, right, you can do it this way as well. Of course, you didn't need to. But anyway, without further ado, very soon we recognize this has to be what? Pi over 6. This is equilateral triangle. So this is pi over 6. We got it, pi over 6. And what about the other reference angle? Right there, it's pi over 6, right? The DRA, right? And you just tidy it up a little bit, and you don't need to do all these geometry anymore. So identify the two terminals, and now angle measurement. How do we identify the angle? To identify the angle, you measure from the standard position, right? And you terminate here, that's pi over 6. You measure another angle, you get 5 pi over 6. Every input is measured the same way. Every angle input is measured the same way. So you also identify pi over 6 and 5 pi over 6. If you choose not to use the unit circle, Now, in the worst case scenario, you're not sure, and we can use arc sine. Okay, because arc sine of half is going to equals to an angle between negative pi over 2 to pi over 2. So we can use that too. Okay, but anyway, let's finish it up. So from this perspective, okay, so I'm going to draw some pictures, okay, in this one, and you're going to draw it with me as well. Okay, you're going to draw with me as well. So we have these, I'm going to draw the y. Let's see how I'm going to draw the y, right? So let's see. There we go. Okay. We have some knowledge about these lines, so I'm going to make it the blue, right? So that's the blue. Let's see if that would do the job. So that's y equals to 1. That's y equals to 1, and r equals to 2. Okay, r equals to 2. So here I'm going to draw the other blue. Okay, so that's identify 1, y equals to 1, r equals to 2. So then you draw that r, because r equals to square root of x squared plus y squared, right? So over here, we got that r, right? R is 2. And you can see, you just draw this picture. I'm just trying to draw it nicely. Okay, so that picture just come with us. Okay, so once you identify these two terminals, and the solutions can also be expressed. Okay, so I'm going to show you another version of the solution. Okay. I wish you to be reminded of arc sine. What is the arc sine of half? Arc sine of half. Arc sine of half is going to be exactly pi over 6. So you're going to be exactly pi over 6. But how do you represent 5 pi over 6 then? You cannot do arc sine. Right here, note, is arc sine half is going to give you pi over 6 for sure. Okay, guaranteed. guaranteed. Any calculator will give you that. It may be a fraction or something, okay? But how do we express 5 pi over 6 in terms of arc sine, right? And this is where you can figure out the relationship, right? So 5 pi over 6 can be expressed as pi minus arc sine of half. So I'm giving you another version of it, okay? If you need to pause and watch it again, okay, remember at the beginning, we talk about, our goal is to develop methods that works all the time, So we're moving towards that direction. Okay, we're moving towards that direction. Okay, so this is the second method. Okay, you just use definition and you also get it. The third method, okay, method number 3 is the function method. Okay, we talk about it in the previous lesson. Right? And how does that work, right? We know, right? We're solving this equation, and we also understand, right? This meaning. We also understand this meaning, right? We understand this meaning. We know the output is okay. We know the output. The output is half, and we want to find the input. We have sine graph. Okay, so sine graph, we're gonna graph it. Look at that. Okay, look at that, sine graph. Sine graph. Okay, I'm gonna give you some more, we're gonna have some more views, right? Say this is -7 to 7, right? So we'll look at that. So when we know the output, what do? We draw a horizontal line. What is that horizontal line? That horizontal line, of course, is y equals to half, right? Because we know the output. And this sine, remember this sine curve is about what? It's about the arc length, right? Or the angle in radian, right? And the blue number, which is a ratio, right? So now we know the ratio is half. Therefore, we're going to draw that horizontal line, which is half. Okay, we're going to make it blue, if that helps. And this blue touches every point, crosses the curve, has an input and output, and every single one of these points. Okay, every single one of these points. Okay, I'm gonna draw some blue bars for you. I'm gonna make it blue. Okay, that's blue. That's blue. Okay, and all of these heights are what? Oops, I'm drawing the wrong place. No, actually, I don't like these. This is just too thick. Okay, let me make it thinner. Okay, let me make it thinner. Okay, the bar. So this is 1, this is half, and that's half. We don't have anything underneath because this will be negative, right? We have positive half. So this will be a solution, and that will be, and for each one of the point, okay, so let's mark these points. I really want you to understand this method. This method is very visual, and very, very useful. Very, very useful. So the first point is pi over 6, comma, half. So we have a solution pi over 6. That's the second point here is 5 pi over 6, and the ratio is half. Okay, so how about on this side? This point, right? What is this point? That's negative 7 pi over 6 half. Okay, how about this point? This point is negative 11 pi over 6 and a half. And we have many, many more. So this horizontal line crosses the curve. It will tell us all the solutions. Of course, there are infinite many of them. There are infinite many of them. Okay, and this is solution between negative pi over 2 to pi over 2, right? So between negative pi over 2 to pi over 2, we have a representation using arc sine. Okay, so let me just quickly draw you the arc sine. Okay, arc sine. I'm going to use what color? Purple. There we go. And of course, I could have make it taller. Okay. Negative 1.6, 1.6. So this better. Oh, geez. Oh, sorry. Wait. Oh, my bad. No wonder it became so ugly. But anyway, you see, this is between, so this is the piece that arc sine also covers. So arc sine could tell us any angle. If arc sine could tell us an angle here, right? Oh, all these things shifted. All these things shifted. You know what I meant. Yeah, you know what I meant. That all these heights are half. All these heights are half. So let me just make adjustment. I hope that this process will help you to understand, right? This process will help you to understand. Okay, I'm not going to change the marking of the point. I'm just going to remark it. So this is 5 pi over 6 half. This is a pi over 6 half, right? And negative 7 pi over 6 and negative 11 pi over 6. Third method. All of these blue bars have the same height. So input, output, input, output, input, output, input, output. We're looking for the inputs, of course. Okay, we're looking for the inputs. And of course, from this picture, you can tell what are the solutions as well. So this is the third method. This is the third method. Okay, so that's a wrap up, right? That's a wrap up. I've done the marking, so just go ahead, right? So I'm gonna clean this up. I'm gonna show you the work, right? The solution, of course, the same solution, right? It's gonna be the same solution, but we can come up with the same solution in all these different ways. Okay, in all these different ways. 3 different ways at least. Okay, 3 different ways. Well, our goal is try to seek method to solve non-special case, right? For non-special case, what do we do? Right? For non-special case, what do we do? Can we still use these methods, these 3 methods? We can, we actually can, because they all have a place on the unit circle. Okay, so let's make this example number 2, example number 3, right? So I'm going to put a number 2, and this is going to be our example number 3. But these are non-special angles, right? Aren't they? They're non-special angles. But you have all the tools already. We have all the tools already. Right? We have all the tools already. All right. Which one of these methods do you think you're going to try? We have 3 methods if it's a special terminal. What if it's not a special angle, right? If it's not a special angle, we can still use that unit circle. You don't have those special values, okay? So I'm going to take this terminal. I'm going to take this unit circle. I'm going to bring it with us. We're going to bring it with us, right? And of course, we don't have that red and blue given to us, but the red and blue is somewhere. I want you to see that perspective, right? Sine, the output is third, right? So the situation is that we are trying to find input such that the output is not half, it's third. What do? We know where's half. 1/3 is smaller than half, right? 1/3 is smaller than half. So there should be a terminal. Okay, there's a terminal. Okay, let's see what color I'm going to use. I'm going to use purple. Okay, so there's a terminal that would terminate here. Okay, smaller than 1/2, smaller than this 1/2, right? Because this is sine ratio, right? So there's still also a blue number. It's just this blue number is not shown on the unit circle, but it is still there. Okay, so let me mark it for you. Okay, so let me put it here. So this point also has a red and a blue. Okay, we don't know what's the red. We can find out. We don't know, right? But we know the blue. The blue is 1/3. The blue is 1/3. You with me? And of course, this is on unit circle. The radius is 1. So that's the question, right? And of course, we also have another terminal. Which is on the other side, which is also, it's going to be a negative red, right? So we have these two, we have these blues, right? This blue is third, and that blue is third. That blue is third. And the red are opposites, right? But we don't need the red. So on the other side, right, there's another point. So you see the perspective, whether it's special, non-special, right? As I said, these special angles are just in service. They're really just in service, okay? They're not the centerpiece, okay? So this other point also has a blue, which is a third, okay? And the red, I don't care, okay? The red number, I don't know. It's, the red, we can draw it. We can draw that red, right? We can find its value. Actually, we can find the red number. Can you find the red value? Of course, use Pythagorean theorem if you want, right? Well, just for the fun of it, we don't need it in this question, right? What is the value of the red? We know the blue is 1/3, and the Pythagorean theorem will give us the red. Right? The red squared plus the third squared equals to 1 squared. Okay, so I'm not going to elaborate on that, but you can if you want to. And here we go. But now, since this is not a special angle, what do we do? How do we identify that angle? That is the question, right? That is a question. What is this angle? How do we identify that angle? this is the moment we are going to use what? We're going to use arc sine. Remember, the range of arc sine is between negative pi over 2 to positive pi over 2. So we can represent this angle in the first quadrant perfectly. Okay, and this terminal will be identified. Okay, so this terminal will be identified, and then you plus 2k pi. Okay, so now here we go. Okay, hold on to it. Okay, so I'm going to write A. Could be two cases because we have another terminal, right? We have another terminal. And we're going to have two possible forms, right? One is that this is the can be identified. This is so ugly. What do I do? Wait. This is so bad. Okay, so I'm going to draw it again. This is just so ugly. I cannot stand it. Okay, so now let's do it. We just identified, right? So there's a terminal. There's a terminal right here, right? And this terminal crosses the unit circle. And at this point, excuse me, at this point, we have a red and we have a blue number. We don't know the red number. We don't care at this point, in this case, right? But we need the blue number. The blue number is 1/3. Okay. And from this blue number, we can identify this angle. This angle is going to be what? Is it going to be arc sine of 1/3? Okay, you can call it theta if you want. Okay, you can call it theta if you want. And plus 2k pi. So all the solutions that ended up on this terminal will be represented. And the next angle, remember we have another terminal, right? We have another terminal, which is just over here. Okay, and this point also has a blue number. And the red number, we don't care. We just, from the blue number, because, you know, sine is positive, right? Now the question is, the range of arc sine is between negative pi over 6, negative pi over 2 to positive pi over 2. So arc sine doesn't represent this angle, okay, it doesn't. But because they have the same reference angle, right? Is a DRA, they have the same reference angle. And therefore, if we measure angle from here, and this angle will be pi minus arc sine 1/3, right? So if I call this theta, so I'm going to call this piece is theta. So hopefully that will make you see better. Okay, does that make you see better? So this is theta, right? So this is theta. And this other angle, the other terminal would just be what? Pi minus theta. And that's where it terminates over here in the second quadrant, and then plus 2k pi. Okay, and of course, k would be any integer. Okay, so you can see in the first method, we can still do this. You can still use unit circle. You just have to know there's many terminals that could be crossing the unit circle. Okay, well, they will all cross the unit circle, yes? In this way, you see the surface position of the special angles, okay? I hope this is clear to you. Okay, if you have any questions, please don't hesitate to tell me, okay? So now that's the first method. how about the second method? Okay, how about the second method? So I'm going to move to the second method. Okay, the second method, of course, we use definition. So this is method 1. Method 1, right? We solve this non-special case and we got the solution. And we also use arc sine. So hold on, we're going to represent theta equals to arc sine. Wait, okay, arc sine 1/3. And k is any integer. So that's how you can represent you can show your answer. Okay. The second method, okay, don't underestimate the importance of the second method. Okay, all of these methods from time to time, you may find them useful. Okay, all of these methods from time to time, you may find them useful. I can totally see you guys, when you're doing calculus 2 and you have a non-special case and you have to use method 2 or method 3, right? But anyway, let's look at method 2. Method 2, very similar to what we did earlier. So I'm just going to bring that picture over here, right? It's going to be the same picture. It is really the same picture. The only thing you need to think of is that the blue bars is 1 and the hypotenuse is 3. Okay, so in the previous one, right, when we're doing 1/2, right, so the blue is 1, the hypotenuse is 2, and in this case the blue is 1 because that's still what is it? It's y over r. Okay, so y over r. You see that? So y is the blue, r is the, square root of x squared plus y squared. Do we care about the red? No, we don't care about the red. So it's almost the same picture, right? If you insist, I can make some adjustment because the scale doesn't measure up, right? Say hold on, the radius is 3, right? The radius is 3 and the y is 1. So 1, 2, 3. And if I want to find the red, because if I find the red, I'll be given a better picture, right? So allow me to do the calculation. So let's see how we do it, right? So this is 1, right? And this is 3, and this piece is 3, right? So what is red? What is the red? The Pythagorean theorem, right? The red is going to be what? The red is going to be square root, right? 3 squared minus 1 squared. Whoops, 1 squared. So it equals to square root of 8. And that's 2 times square root of 2. Right, so the red is 2 times. So the red is equals to 2 times square root of 2. So now I can draw the picture better, okay? Because I know both the blue and the red and the blue, right? So I'm gonna do that. I'm gonna do a better job. So there's no so there'll be no complaints, right? Square root of 8. And that's the blue, right? And the next one, square root of 8, square root of 8. Wait, okay, hold on. I'm just allow me, okay? And you are thinking how you're gonna draw this picture, right? So the red is 2 times root 2. And so this is a different picture. similar picture. Okay, just allow me to draw a nicer, more concise picture to this question, right? The red is 2 times root 2 square root of 8, and the blue is 1. Okay, so I'm basically making some modification. Yeah, the blue is done correctly. Oh, there, that one is done correctly. And this is going to be root 8. And that's going to be root 8. I think that's all I need to do. There we go. And if I want to mark the red, right? Some of these things you don't need to do, but just give you a perspective, because some of these aspects, it can be very useful too, okay? I'm drawing the red, right? The red is going to be root 8, 0. You see, all of these can be done. Okay. Another one. Red, blue, red, blue. Okay. You see, it's the same picture. It's the same picture. Okay. It's the same pictures, or almost the same picture. I'm sorry. Almost the same picture. So this is pieces 1. Whoops, sorry. I don't need that to be red. That's be blue. So this is 1, right? And this is 3. 1 over 3. You see, 1 over 3, right? And the blue and the red is just a bonus, right? We can get from Pythagorean theorem. And the red, all right, the red is 2 times root 2, which is root 8, right? And this other red is a negative 2 root 2. But we don't need these red numbers. We really don't need the red numbers. Okay, I'm just showing you so we get a good picture. We get a good picture. Okay, and so I would say this is a similar picture to the method 2 when we did with the special terminal, and for non-special, similar, completely similar. So let's get the solution. Let's get the solution. How do we get the solution? Same solution. It's going to be the same solution. Okay, so what are the same solution? And this angle is theta. Can be represented by arc sine. Okay, so you're going to assume theta equals to arc sine of 1/3. You don't need to worry about its value. It's going to give you a value, okay? And your math professor will most likely to have a preference for you just show it this way, okay? If you punch in the calculator, it's going to give you an angle between 0 to pi over 2, because this is a positive ratio. You expect a positive angle between 0 to pi over 2. But you don't need to punch that calculator. You don't need to punch that in calculator. Your math nerdy professors, they most likely like for you to show the answer in the most precise way. That's why we keep telling you, give us the exact value. Give us the exact value. Okay, so this is theta. And what's the other one? The other one, okay, they have the same reference angle, right? That's why with DRA. So this other angle is going to be pi minus theta. Sorry, this is so ugly. Please forgive me. Okay, so this is a pi minus theta. There we go. Right? So the solution would be still the same drill. Right? The same drill. Right? So it's theta plus 2k pi, or pi minus theta, oops, minus theta plus 2k pi. And k is any integer. Okay, sorry, but the picture just messed up. Okay, so you got it. If you have a question, let me know. Now you come to the third method. The third method is very interesting too. Okay, I wish you to show that. But here I want to borrow the previous picture. Why? Because I want you to see the similarity. I want you to see the similarity. That's why. Okay, method 3. Method 3. In the previous example, when we have a special terminal, method 3, right? For the same question, right? The same story. The output is given, we draw the horizontal line. Last time we draw horizontal line 1/2. We will still have that line here. So here we just draw 1/3. You see that? We just draw 1/3. We just draw 1/3, right? 1/3 is not special, but it's okay, right? 1/3 is not special. So we see that there's all these points. Okay, there are all these points that are solutions. Here, there, there. All of these points. All of these points, and there are infinite many. What do they have in common? They all have the same output. They all have the same output. The same output half. Third, sorry. It's the same output third. And we just have to identify the inputs. Okay. And this one, this angle can be measured. Okay, can be represented by arc sine 1/3. And it's going to fall between 0 to pi over 2. You see, between 0 to pi over 2, right? And that's how you see the visual of all these horizontal, all these points with the same output. Remember, the question is to find all possible inputs such that the outputs are all 1/3. I hope this is very, very clear to you. Okay. And this idea is very, very powerful. Does it work for all? The answer is yes, it does. The vertical idea, vertical line idea, the horizontal line idea, do they work all the time? Absolutely, yes. Okay, that's why we talk all 3 methods. We talk about all 3 methods. Okay, so how do we represent, how do we find this angle? The angle is arc sine 1/3, okay? You see, you got it, right? So then once with this understanding, and of course the solution is what? The same. Okay, the solution are the same. It's the only difference is that instead of being pi over 6, right? And the angle is just going to, this piece is, let me make it thicker. Okay, this piece, this input, this piece is arc sine 1/3. Okay, this arc sine 1/3. Between what? Between negative pi over 2 to pi over 2. And this is a positive ratio, so it's going to be between 0 to pi over 2. And once we find this angle and we found there's a pattern using reference angle, so we identify all of the other angles. Okay, so pi over theta, pi minus theta. So the other one would be what? Would be this one, right? Pi minus theta. So this is a pi minus theta. And all of them, they have the same output, 1/3. All of the same output, 1/3, 1/3. That's blue is 1/3. So now you understand why we use those color tone to illustrate, and we're being consistent with those color choices, right? And you can make those connections. All right. So now it comes to the third one. Example number 3. We have a negative ratio. It's not a special. Okay. In order for you to see better, actually, I'm going to move this as the example number 4. I'm going to insert example number 3 with a special angle. It's a special terminal. Okay, so we can understand, because it's going to be a little bit tricky. Okay, so this one I'm going to choose to be sine of the angle equals to -√2/2. And we know this is going to be a special angle, right? And once again, we can use any one of the 3 methods. And from the unit circle methods, right? So let me bring my unit circle here. And we know the output, right? It's the same drill, right? So angle is the input. We're looking for angles, and the sine function is applied to the angle, right? It produces a ratio, and the ratio is given. So the output is given. It's still the same story. You can see it has to be absolutely consistent. Okay, -√2/2. So since this is a special angle, then you have this unit circle, no problem. And you're looking for the -√2/2, and we found them right here. There's one here, and there's another one there, right? And then there are reference angles. What are the reference angles? Pi/4, right? And reference angles, there we have 2 terminals. So what are they, right? You can say, oh, this is 11 pi/4. And you can also say this is -pi/4, right? This is -pi/4. And this other one, because this is simpler, right? So we choose a negative angle. There are many choices because each terminal corresponds to many angles. But anyway, so this angle is a -pi/4 as we measure, because we're looking for a solution for A, right? So now let's write down the solution. Okay, let's write down the solution. And of course, we have 2 forms, right? Oh, look at that, so ugly. Oh, forgive me. I'm going to, you know what I'm doing, right? So now I'm just going to write it down. So here, this is going to be -pi/4, right? Plus 2k pi. And the other one, there's so many ways to represent it, right? It's actually -pi plus pi/4. So I'm going to write -3 pi/4. How about that? Okay, -3 pi/4. You don't have to. You have the solution has many different forms. Okay, has many different ways of writing it. Even for the same form, there are different ways of writing them. And I'm writing down this one. Okay, this time I'm not going to do the second method for this one. Okay, so we just got this. right? And you can also think of the curve, right? You just cut it. We're gonna do the third method. We're gonna do the first method and third method. We're skipping the one in the middle. Okay. And here we go. We get all the solutions. Let's talk about method 3. Okay, we have the correspondence. The method 3 consistently. This time we're skipping method 2. If you want to do it, go for it. Okay, if you want to do it, go for it. Because after these 2 examples, we're going to wrap up today's lesson. We're going to wrap up this lesson. Okay. The curve. The curve. Method 3 is about using the curve, right? Method 3 is by using the curve. And here we go. Here we go. And instead of cutting at 1/3 or 1/2, this time the horizontal line is what? Is a negative √2 over 2. See? There you go. Okay. So what are the solutions? Right? So what are the solutions? It's the same drill. Okay. And this time, right? Because our output is negative √2 over 2, so it's a negative number, right? So all these blue bars we're drawing, right? What are the blue bars we're drawing? Which one? So we get all these points, right? We get all these crossings. We get all these crossings, don't we? Right, there are crossings on the other side, right? So for all these crossings, the blue bars are, oops, get rid of that heart. The blue bars, and there's one here, and there's one here, and there's one here. Oh, I almost missed that one. Negative pi over 4, and that's you know, we have many solutions, don't we? And all of these blue bars, they are equal to negative √2 over 2. Okay, that's how high they are because they are negative. So it's underneath the x-axis, right? With 1/3 or 1/2, it's above x-axis. Now it's negative, so it's beneath x-axis. And among all of these bars, only this one blue can be represented by arc sine, which is arc sine of negative √2 over 2 is negative pi over 4, by the way. Okay, I just pointed out. I just want to point it out. Okay, but because these are special angles, we get all these terminals, right? And you just have to represent, we represented this piece and we represent this piece, and then we just plus 2k pi. Okay, so this is a negative 3 pi over 4. Okay, this is a negative 3 pi over 4. And what is this one? What is this one, right? Can you figure that out? What is this one? Yes. I'm gonna leave that for you to think, right? Well, it's pi plus pi over 4, right? Yes, it's pi plus pi over 4, so 5 pi over 4, okay? And this is what? This is 11 pi over 4. No, I'm sorry, 7 pi over 4, sorry, my bad, 7 pi over 4. So there's a bunch of negative, a bunch of negative, positive, all these angles can be represented, right? So we get the same solution still. We get the same solution still, no problem. So now finally, we come to example number 4. We have done all these preparations. We've done all of these preparations. And this one probably among one of the harder ones. Okay, because number 1, it is not special. It is not special. Okay, but I still want to give you a brief about the perspective on unit circle. Okay, the brief of perspective on unit circle. So we're going to talk about all three methods. We're going to talk about all three methods. Okay, so method one. All right, this lesson actually is pretty long. If you guys need to take a break, feel free to do that. Okay. I just want to be, you know, I want to be consistent. Okay, instead of breaking them up. Okay, so now we have this situation. Okay, we have a special, again, we have, oh, where's my unit circle? Did I lose it? Oh, sorry. Here's my unit circle. First, look at the unit circle perspective, right? We've been talking about the special angles, special terminals. They are in service to ARD. Well, this is why. You see it once again, right? You don't see -3/5 as a blue number anywhere, but it is somewhere. It is somewhere. Where is it? Well, it's -3/5. So it's going to be in the third quadrant and the fourth quadrant, right? And we have -½ here and -√2/2 here. So -3/5 is somewhere in between, somewhere. Okay. So for these two terminals at the crossing with the unit circle, okay, they are blue numbers. They are blue numbers. So on this point, at this point, okay, so let me point it out. And this point has a blue number. The red number, we don't care. Okay, the blue number is -3/5, 0.6. And this one as well. This one is also. Okay, so this one, this point also has the similar feature. Just the red numbers are. We're not going to bother to find it. Do you follow me? I hope you follow me. Okay, -3/5. The red number, we can find it. We can actually find the red number, right? Remember that homework questions, right? You use that, you know, Pythagorean theorem, and because the hypotenuse is one, is one, and you have, we know the blue, right? We know the blue. We know the blue, -3/5, right? We know the -3/5, so we can find the red if you want to, right? And actually, the answer to the red is almost there. Okay, and I can totally hear you, even though you're not in my lesson right now. I think I can hear you. You're telling me the red, the value for the red, right? What is it? Pause the lecture if you want to. Well, this red is the 4/5, right? This red is -4/5, right? So you know it. But anyway, so that's the perspective. That's the perspective. So we still have a place on the unit circle. This is how we could use the unit circle, okay? And even though we don't need the red, so I'm just gonna put them away. How do we represent our solutions? How do we represent our solutions? You see, this terminal falls into the range of arc sine. Arc sine's range is between -π/2 to π/2. So if we call this angle theta, this angle is theta. How do we represent it, right? These two terminals have the same reference angle. So this piece is theta, so that piece is theta. And this is the time we're going to represent these angles. Okay, so let's allow me. Okay, allow me. I hope nothing moves. Okay, nothing moves. There we go. There we go. So theta, okay, arc sine of -3/5. This is the angle. And this angle for sure, from our knowledge about the range of arc sine, it's going to be between 0 to -π/2. So actually, I should write it -π/2 to 0. Okay, smaller number on the left, the larger number on the right. So this theta for sure is going to be a negative angle right here, clockwise. So arc sine give us a value like this. And how do we represent the other terminal? That's the hard part. That's the little tricky part. So you have to think about, how do we represent this angle? Because every angle is measured from standard position. Okay, you can measure it this way, right? To reach that terminal. And you can also measure this way. I would like you guys to pause the lecture at this point to think about it. Okay? Knowing that theta itself is negative. Theta itself is negative. Why? Because arc sine's range. All right, so let me tell you the answer. Okay, if you go by this way, right, it's basically pi, right? You measure from standard position, you get here at pi. All the angles as input for sine, they're measured from standard position. Okay, that's the importance of the ARD, right? So I'm measuring by that rule. So this is pi plus theta, but theta itself is negative. Okay, so normally you would do that pi plus theta, but here we need to do pi minus theta because theta itself is negative. Only you put a negative sign, you make it positive. Okay, so this is the tricky part. Okay, how about this one? How about if you can use either one, because we can do theta plus 2k pi, and then we also need to measure this one, right? How about we do this one, this piece? This piece is measured clockwise, right? So here is a negative pi. Okay, this is a negative pi. So in this case, you just have to do what? So this is theta. So in this piece, it's actually negative pi minus theta. Okay, think about it. Okay, I'm being very careful here. Why negative pi? Because I'm measuring clockwise. Negative pi. And then if I measure negative pi, I'm coming here, right? I need to come back. So I need to add, I need to subtract that angle, but that angle itself is negative. So I need to add this angle. Okay, so I need to, so this is going to be negative something, so it's going to be minus theta, because minus theta, the effect will be negative pi plus that angle, the actual size. Okay, think about it. I'm thinking about it, right? You want to come back as a counterclockwise, right? So negative pi minus theta. So anyway, we're going to put this answer down and we're going to go back to example 3, right? Remember we did the example 3, we tried to verify this, right? So I'm going to give you some points of reference. So before that, let me write down the solution for you. Okay, so let me write down the solution for you. So here we have the angles, the solution equals to All right, so, what an ugly thing. But anyway, so it's going to be, the first one is theta plus 2k pi. That's very easy. Okay, the next one you can use, I'm going to use pi minus theta plus 2k pi. Okay, equals to, well, k is integer. And we're going to verify this. We're going to verify this. How do I verify this, right? You know, sometimes, you know, I need to verify it too. I just want to make sure I'm have done this correctly, right? Especially when, you know, theta is negative. So I'm going to take this answer. I'm going to take this answer and go back to the special case. To the special case. Okay, so this is how we do, you know, just as a point of reference, right? In the case of this example, okay, so because if we made a mistake, we can go back to make the adjustment. Okay, don't think I will never make a mistake. I do too. Okay, so in this case, theta is negative pi over 4. Okay, theta is negative pi over 4. So when I do pi minus theta, there's another form too, right? There's another form too. I'm going to put the other form, or that was a negative pi minus theta, right? Now, negative pi minus theta, when theta was negative pi over 4, right? I should get this piece. I should get negative 3 pi over 4. Is negative pi minus negative pi over 4 equals to 3 pi over negative 3 pi over 4? Yes, it does. So this form is correct. This form is correct. How about this form? How about this form, right? This form didn't show up here. And also we want to see if this will give us a meaningful answer. So I'm going to replace theta. I'm going to replace theta by negative pi over 4. Oh, sorry. This is, okay. If I replace theta by negative pi over 4, this is going to be pi minus negative pi. So that's a plus. That's a plus. And this will end up to be 5 pi over 4, right? 5 pi over 4. 5 pi over 4, where does it terminate? It terminates here. So we are right. We are right. So this is 5 pi over 4. So either form gave us the right answer. Either form gave us the right answer. I know this is a little tricky, isn't it? This is a little tricky here. So it's a representation. It's knowing that theta itself is negative. Theta itself is negative. So this form will do. Okay. So I'm also going to give you another form. Optional. You don't have to show both, right? So it's a negative pi minus theta. Is that what we did? Minus pi minus theta, pi minus theta, right? This is a pi minus theta. So either one works. Just make sure you understand that theta itself, right? Theta itself is negative in this case. So it's a little bit tricky. It's a little bit tricky, okay? But now overall, you look at this form in the negative ratio case, and you look at the form in the positive ratio case, there's actually no difference. They're all the same answer. Don't you see that? This is the case when we have 1/3, right? And this is the case we have negative 3/5. So we get the same answer, don't we? Don't we? Okay. Method two, using definition. method 2. We're going to use definition. Okay. The reason we want to use this because these methods can be in the case that we have a non-special case. It's very important that you know how to handle it. You know how to handle it. Okay, so I set up my rectangular coordinates. Okay, and I'm going to make some. I'm going to make my adjustment. Right, it looks like this is the 3, 4, 5 case, right? So we got it 3, 4, 5 case. And the ratio, remember, using definition is very, very important. Very, very important. Okay. And by this time, right, this time we understand the angle is the input. Okay, we're kind of repeating the same theme. The output is a -3/5. Right, it's -3/5. So we kind of know this is a y over r. Right, so y is -3. R is 5. Right, so let's see if I can make that fonts adequate. You see the -3, right? You see the -3. Okay. Well, we know that y is -3, r is 5. That's what we know. So we can draw those terminals. So what are those terminals? What are those terminals? What are those terminals? -3, and we know the height is -3, right? And we know that 3, 4, 5, right? So we kind of already know x is going to be 4, right? And so it's going to be a similar picture. It's going to be a similar picture. So I'm going to draw these, right? So one is 4, -3, and 0, 0. So that gave us the r. Oh, hold on. That's the r. That's the r, right? And keep going. We want to draw the blue, right? So this is going to be the blue. We're really just using definitions all day long, don't we? Don't we? We use the definition all day long. That blue is -3, -3. And of course, we have another one, right? And we have another blue. There. It should be this one. So right there, the blue, right? So this blue is -3, that's blue is -3, it's 5. This is the power of using definition, okay? Using the power, this is the power of definition. And once again, right, we don't need the red, so we're not gonna worry about the red. You know how to find the red. So this angle, theta. And this theta can be represented because it's in the range, well, first quadrant, fourth quadrant, right? Remember when we work with arc sine, we chop off quadrant 3 and quadrant 2, right? So this angle can be represented by arc sine, right? It's going to be a negative angle. So we're going to come up with the same answer, and the rest is similar. The rest is similar. Does that make sense? So it's just how you apply the output. How do you make use of output? And the power of definition is once again coming to our rescue. And now, so without further ado, I'm just going to give you one version of the solution. One version of the solution. And of course, we're going to talk about the third method. The third method is so powerful, so powerful. Okay, so I'm still going to borrow my curve because I want you to see the similarity. Similarity. I know some of you might be bored at this time. Oh, I got it. Okay, very good. You got it, right? Go ahead and do the homework. So instead of drawing the horizontal line, which is negative √2/2 or 1/2 or 1/3, this time we're going to draw that horizontal line to be negative 3/5. There we go. Non-special, right? And we got all these points. Yay. All these points, those are the solutions. Those are the points that we have the same output. We have the same output. We just have to identify the inputs, right? Because that's the nature of the question, right? The nature of the question, we are to identify inputs such that the output is negative 3/5. Right? That's the nature of the question. Yes. All right. So, and of course, in the end, our solutions, whoops, why do I do that? Right? Our solutions, the same solution. And on this picture, right? On this picture, okay, on this picture, you can see all of these points, right, being marked. Oh, wait, sorry, I copy and paste the wrong thing. Did I? Oh, that's terrible. Oh no, not this one, my bad. I'm sorry. Okay, I'm gonna copy this version of the solution. Forgive me, okay? So this is the solution. Of course, the solution are the same. Could there be variation? Yes, there could be variation, okay? Your solution could look different from someone else's, but you could both be right, okay? Because you can see there are multiple representations. There are actually many, many ways of representations. But all you have to do, you just have to make sure both terminals are covered. Okay, but how do you represent those terminals? There are as many ways as there are possible. Okay, so without further ado, so this is the all the cases from special to non-special. Okay, to solve these simple trig equations. Okay, so that's what we have done this time. Okay, if we do this thoroughly, right? I would say if you understand these methods I've talked about, and it's going to be similar to cosine, tangent, cotangent, secant, cosecant, and you will be invincible. Okay, last example. Okay, I know this is last lesson is kind of long. Last example. Okay, solve for so this time we get sine, right? So still solve for a, and sine of a equals to -3. What will be the solution? Remember, this is an if statement. Right? Remember, this is if statement. All equations are if statement, right? If the sine ratio is -3, and we are to identify, Michael, okay, I hope you're not too tired. Okay, we know the output is -3. And we want to identify, find all possible values for A. whoops, such that you know what, I think I'm a little tired too. Okay, such that that's true. So what are the solutions? You can use any method you want, but then you say, wait a second, what is the range of sine? What's the range of sine? Yes, that basic knowledge about domain and range for sine. This is true for any value A. So for any value, sine will never be exceeding 1. It will never be below -1. So what do we have? Do we have a solution here? Of course, I hear you. No solution. Yes, so that's the power of knowing the function. Okay, think about all the work we've done, all the work we have done, right? To get to this point, Now we can look at ARD, we know how to do ARD, DRA, so on and so forth. Okay, this lesson is pretty long. Okay, I expect you to see it from time, take breaks, but we covered every aspect about the simple solution of solving simple solution involving sine. Okay, I will see you guys next time. Thank you for watching.